something like that. All right, and we're live. All right, here we go. Here we go. This is complex polynomials, complex numbers that are in the form polynomials. This is 2A.2.2, and a lot of this is review. Really, we're building on this knowledge, and we just have to bring back the idea about complex numbers. So, if you guys remember this, there's a real and an imaginary part of a complex number. The real always comes first, right? So, and one thing we can do, we can never combine these. It's the same as if you had x or x squared or any variable and a number, constants and variables you can't combine. It's the exact thing over here. That imaginary number, the reason why that was created in just general math was they got to a situation where you had the square root of a negative number. And just remember the square root, if it's the square root of 64, that's asking what times what gives us 64. Right? It has to be the same number twice. 8 times 8 gives you 64, but if this was negative 64 in there, what would we need? We need one positive 8 and a negative 8, and that's not the definition of a square root. So they, the mathematicians, we talked about it last year, I don't remember his name, but when we talked about him, we know that he used the I to represent the square root of negative 1. Okay. And if you think about this, if you had the square root of negative 64, like we were just talking about, you can make that into the square root of negative 1 times 64. That way we could pull out that the 64 would become 8. The square root of negative 1 would be left over, so it would be 8i. Okay. So really what we just have to remember with the I values is that I to the first power is square root of negative 1. I to the second power is negative 1. These two that I starred are the main thing. So if you didn't star it on your page, those are the main ones you want to star because those are going to apply when we multiply our polynomials. Okay. I'm trying to make a new joke about real and imaginary. I'll keep working on it. I'll bring it back. Remember the jokes from your imaginary friends? You don't want to tell those to your real friends, okay? Because that doesn't work out. Or if I'm going to try to make a bunch right now. Okay. You know how when you don't have enough people to play baseball, you only have 4 people and you have imaginary runners? So you get a single, you put someone on first. Okay. So what if it's a real game, it's a varsity game, you're like, you hit, and you say imaginary runner, and you go back and try to hit again. Is that going to work? No. You don't bring imaginary runners in a real baseball game. If you have an imaginary, you have a dream that's kind of in your imagination. It's an imaginary happening. And in your dream, you became the ASB president. And then so you decide, I'm going to go to school. And you don't remember if it's real or imaginary. But what's the one way you could find out if it's real or imaginary? You could walk into the ASB room when they're having a meeting. You could say, I'm in charge here. You don't want to confuse things that are real and imaginary, just like we never combine real and imaginary. And I don't have another one, so that concludes the imaginary and real segment of this lecture. All right. Next, let's look at each of these problems one at a time. This first one is just getting us used to it. Remember, the one thing I'd suggest if you get confused with, well, how am I going to multiply these? This is really just 4 times 5 times I times I. When you're multiplying, because this is 4 times I right here, this is 5 times I, and they're being multiplied together, it's really that commutative property. It doesn't matter the order because you're multiplying. Commutative property of multiplication says it doesn't matter the order it's in. 4 times I times 5 times I is 4 times 5 times I times I. You can move them around to see it easier. So what am I going to do? I'm going to go ahead and put 20. I'm going to put I squared, and then I want to look at my identities. Go ahead and on your own, figure out what your final answer is going to be for that. All right. If you're not sure, check with your neighbor. Maybe they'll give you a hint. You definitely should be looking at these 2 starred items here. 2 starred items. Also, if you get confused with this, I want you to put parentheses around everything. You see, I put parentheses here so I don't get confused that it's 20i squared. It's not 20i being squared, it's I squared over here. So Jordan, what do you think we're going to get when we go I squared?
-1.
-1, so we get?
-20.
Oh. I knew you knew by your attention and concentration on the problem. All right, thanks. Good job. Let's look at the next one. What are we going to use here? Just like last week. What are we going to use? What's our method? Okay, good. You could use the polynomial identities, but really that is what FOIL is. What does FOIL stand for?
First, outer, and last.
First, outer, inner. All right, so first things first. What are we going to do? Who's up to go first? Does anybody have that first inclination on what we should do first? Fine.
Multiply 2 by 3 and then 2 by I.
Because those are the first. Slow down. My joke is ongoing. It's longitudinal. The first is 6. All right, so I know this is like kind of an outlier idea. It's way out there, but what are we going to multiply next? And, outer. That one's not as fun. Plus 2i. Okay, I want you to go deep. Your inside wisdom, your inner wisdom.
I believe in you. You got this.
I'm going to fumble through it. So the inner 3i. I know it's good if Michaela kind of just looks down. She doesn't want to get eye contact to be able to have to affirm it or not. Just gonna look at my page. That's cool. It gives me a lot of peace. All right, last but not least, the last thing we're gonna do is multiply the. All right, I'll do better next year. Like you remember that.
You're doing well so far.
So far, so good.
I'll give you a solid B.
B. I'll take the B.
That's passing.
Does that mean best? All right, hold up. We have I squared. I squared is equal to what? -1. So I'm going to end up with 6 and a -1. This is really -1. 6 and -1, 5. That's our real part. Plus 2i plus 3i. So remember, when we're adding them, we added just like this was 2x and 3x. It's 5x. I is not a variable, but we can still deal with it as if it's these are like terms. This is I and I, so it's 2i plus 3i, 5i. 6, the I squared was -1, so that's why it's 6 minus 1. So far, so good. Really, it's nothing new, right? We just have to apply it, kind of remember it a little bit. Okay. All right. Go ahead and tell me, what is similar between these two binomials? What is similar between this expression and this expression, and what is different? What's similar? What's different? Mind blown. You want to answer?
Pass.
Pass. Anybody else want to pick that up?
They're both 2x, but one's a negative I, one's a positive I.
Good. So as far as the terms involved, we have a 2x and we have an I. We have a 2x, we have an I. But this one's addition, that's subtraction. Perfect.
That's crazy.
What's that called?
What is that called? Echoing you. I'm echoing you somehow. I'm lecturing, I'm echoing you. What is this called? You guys remember it starts with a C and it's 2 words. It's actually 2 words, C and C. They both start with C. It's a really complex word. Complex communism is close. I like that. I like that. I want to make something up.
Cake and cookie tomorrow.
Yes. No. Complex. I see that potentially I didn't teach this to Math 2 last week. Bring it back, bring it back. Complex, I want you to write this down. Alright, hold up. If you're getting distracted, this is a key new idea. It's not in the notes, but it is called the complex conjugate. Now with the complex conjugate, what ends up happening is we get rid of all our imaginary numbers. So complex conjugate, you can even write it, gets rid of imaginaries. Okay, it's really helpful when coming up we're going to have a complex number on the bottom of a fraction. In order to get rid of it, we'd multiply by this complex conjugate. It's always the same terms, but one is plus, one is minus. It's going to get rid of all of our I values. So we're going to use FOIL once again. I want you to get as far as you can with this one. FOIL, one thing at a time. Multiply the first. I'll start us out. 2x times 2x is 4x squared. Now do the outer, the inner, and the last. It's probably going to be a little tricky at some points, but you'll see something nice happens quickly. Something nice, really nice happens. All right, this is going to go over here. Just can't see that. Okay, so we just multiplied the first. Now let's multiply the outer. 2x times negative I. That is kind of weird, right? So I'll do this one with this. Okay, it's negative 2I x. How about the inner and the last now? So it was 2x times negative I, and I put the I next to the coefficient for simplicity, because I is a value. It's a number. Okay. All right. Who feels pretty confident wants to help me out? Someone who. Thank you for raising your hand. Anybody else new that hasn't raised their hand today? Help me out. 4x squared minus 2ix. Iris. Plus 2ix. Lastly. Remember we just did the minus I to what power? There we go. So I'm going to put it like that to kind of help me remember that I squared, we can go to our identity over there and figure it out. What happens to these middle terms? And negate out. They're gone. 4x squared. Why is it plus?
Because it's negative 1, but then there's already negative 1. This means combine the two.
Good. It's just negative I squared. I squared is negative 1, so it's negative times negative 1. Awesome. Okay. So you'll get used to doing these pretty quick. Just know when you have a complex conjugate, it's so messy. Complex conjugate, you're going to get rid of all your imaginaries. Okay, we got 2 more to do, and then I'll switch to classwork. This right here, wait, I erased the wrong thing. It's going to be all right.
X plus.
X squared.
It was X. It was.
This is what we're going to do for example 4. What is it? It's okay, I showed you the answer. If you put the other thing down, you have the answer already. So we'll just work our way backwards. You already have the answer. What we're going to do is, notice down here, we went from 2 binomials and we got to this final answer using the complex conjugate. Here it's kind of the opposite. So we're going from the answer to these 2 expressions that will have imaginary numbers. We're going to go the opposite direction now. So first off, complex conjugate. What does a complex conjugate always have? It has one what? One negative. So I know that my answer is going to have this in it. We know that the first terms have to multiply to give us that first term in our final answer. So those are x's. I know that the other terms we have to figure out, they're also going to be the same term. I know they're going to have an I in it. So Brian, what do you think? What can I put in there? Just one I? Let's see. One I in each one, but how did we get to this 9? Almost. Yeah.
It's not coming in my head.
Okay. That's okay. Anyone else? Blake, what'd you think?
Maybe try putting 3 of each of the others.
Let's see.
Oh, yeah.
it's pretty quick. I mean, you look to see. I know it's going to be x squared, so x and x. I know it's 9, so it has to be 3 times 3. But then remember, this is a complex conjugate because it has the I value in there, because it's a complex number. Okay. So just keep that in mind. The complex conjugate only applies when we have complex numbers. Complex. Who thinks this one here, number 5, looks really tricky? Looks tricky. Or not? It's not tricky.
It's not.
It's not.
It's not.
Okay. All right. So I'll let you work on this one for about a minute. I'm going to give you a minute for this one. Okay. So we have 5 plus 5i, 5 minus 5i, complex conjugates. On the bottom, 5i times I. So first work on it for a minute, and then check with your neighbor. Or if you both have the answer ready, double check each other. Okay, if you wrap that up, double check with your neighbor. If you're still working on it or you got stuck, just notice where you're at. We'll finish it up. All right. But it's not 25i for that second term. So it's going to be 5i times negative 5i. So we get negative 25 times squared. Got it? Let's work it out. Okay, here we go. Want to make sure everyone can hear. All right, wrap it up if you're checking with your neighbor. Wrap it up if you're checking with your neighbor. What's going to happen on the bottom? 5i times I. Let's even do it in baby steps. That's 5i squared. We can deal with that. So we know we can deal with that later. On the top, these are, what are these called? These two expressions are what to each other? Complex conjugates. So I know what I'm going to end up with is 25. That's the first. The outer and the inner are going to cancel each other out because that's the definition. That's what happens with the complex conjugate. I could write it out, but is everyone okay with? I'm going to write it out. So we end up with minus 25i plus 25i. And then last, we end up with negative 25 and then an I squared because it's 5i times negative 5i. Now watch. What happens to these two terms? Gone. We have 25 on top. What's I squared? I squared. Negative 1 times negative 25. Good. Negative times negative. Negative 25 times I squared is negative 1. Positive 25. And then down here, this is negative 1 times 5. Negative 5. 50 divided by negative 5. Negative 10. Who got negative 10? Good job, most of us. Good job. All right.
Yeah.
First time coming up. 23. All right, we got about 25, 26 minutes. So here's the deal. Because we have so much time, I'm going to come around and initial When you get through the workbook, page 53, 1 to 7. Have me come around and initial it. I'll put up the worksheet, that's the homework. Everyone has a very good chance of finishing everything in class. Then we won't see homework again till Thursday, which is days away. All right, forgot to say subscribe or something. Did anybody think of something better I could say? I feel like I've just maybe said that every time. Say again?
I said Mr. P's the name, math is the game. Subscribe.
Wow.
That's a good one.
Oh. Wait, I have to do the subscribe. All right, ready? Ready? Yes. All right, Pasillas is the name, math is the game on 3. 1, 2, 3. Subscribe on 3. 1, 2, 3.
Subscribe!
We can do that one.